Does the table model direct or inverse? So direct variation takes the form y equals kx. An inverse variation takes the form y equals k divided by x. So to check to see if something is direct, if a function models direct variation, your k is going to be equal to y divided by x. So you want to check, if I divide y by x, do I get the same number every time? In this case, you don't, because 0.9 divided by 0.8 is not the same thing as 1.2 divided by 0.6. So then to check for inverse variation, this would mean that xy equals k, or y equals k divided by x. So if you multiply x times y, you're going to get the same number. In this case, it's 0.72. So that's your k, your constant of variation. So my equation is going to be xy equals 0.72. You could also write it as y equals 0.72 divided by x, but you don't want to mix fractions with decimals. Number 8, suppose y varies inversely with x. So this would mean y varies. I always write y equals. If it's a variable varies, then I write that variable equals. Inversely with x means that x goes on the denominator, and directly with z means it goes in the numerator, kz. So you always need to add this constant of variation in the numerator. So then I'm going to use the second piece of information, that when x is 2, y is 3, z is 6, and solve for k. So when y is 3, k I don't know, z is 6, and x is 2. So I'm going to solve for k by multiplying both sides by 2. So 6 equals 6k, k equals 1. So now I have this general equation, which is y equals 1, which is k, z over x. So this k is 1. It didn't really even come into play right here, 1. So next thing, I'm going to use the second part of this information, the last part, write a function to model this. Did that. Then find y when x is 1 and z is 7. So find y when x is 1 and z is 7. So 7 divided by 1 is 7. So the answer is 7. Number 9, write an equation for the graph y equals 3 over x with these asymptotes. So it's going to be y equals 3 over, but if you have an asymptote of x equals 1, that means that if you let x be 1, the denominator is going to be 0. So this has to be x minus 1. And then this asymptote this graph is shifted down 2, so that's why it's negative 2. So I'm going to draw my asymptotes first at x equals 1, it's a vertical line, and y equals negative 2, a horizontal line. And then what you want to do is you want to plot 3 points on each branch. So I know that since this value right here is positive, it's going to be happening, the numbers are going to be in these two quadrants with respect to these two asymptotes. So you can plug in numbers for x and see what y is, but I'm just going to use my table feature on my graph and plot specific points. So negative 2, negative 3 is a point, negative 1, negative 3.5 is a point, negative 3, negative 2.75, so that's considered one branch. So I'm going to connect these. It's not the best, and then I'm going to get on the other side of the branch. When on my calculator 1 is showing as an error on my table, that's because that's where there's a vertical asymptote. So I have 2, 1, 3, negative 1.5, or 3, 2, 1, I didn't graph properly here. 2, 1 needs to go over 2, up 1 from this coordinate. So go right 2, up 1 and make your dot. So I almost did that wrong. So 2, 1, and then 3, negative 1/2, and then 4, negative 1. So this is another branch. So you want to get your graph to be close to the asymptote but not cross it, and make sure that you have arrows at the end of it. Okay, number 10, write the equation for these asymptotes. So and my asymptotes are going to be x equals 1 and y equals 3. Number 11, find all points of discontinuity. So points of discontinuity can be holes and vertical asymptotes, and also horizontal asymptotes. So what you want to do is you want to factor out the numerator, and then you want to factor out the denominator. So holes take precedence. So the hole is going to be at x equals 2. After you find the hole, set your denominator, after you cancel out the hole, equal to 0. But you can't set 3 equal to 0, so there's not going to be a vertical asymptote. Horizontal asymptote, you want to check the degree of the numerator and the denominator. So if the degree of the numerator is greater than the degree of the denominator, which it is, there's not a horizontal asymptote. If the degree of the numerator and the denominator are the same, then you're going to do the ratio of the leading coefficients. If the degree of the numerator and the denominator, if the bottom has a greater degree, it's going to be y equals 0. So I'm going to draw in my hole. Well, actually, I'm not going to draw my hole in. I can't draw any asymptotes. So I'm going to put this in my calculator. Just make sure that this whole thing goes into y1. Okay, and then you're going to want to put parentheses in the numerator and the denominator. So I'm at my table and I have the points. It looks like a linear function, -2, 0, -1, 1/3, 0, 2/3, 1, 1. And then there's an error at 2. So that error, so I'm going to connect these right here. That error means that is where you're going to have the hole right here. So at 2, I'm going to make an open circle to represent my hole. And then number 12, multiply and divide, state any restriction. So I'm going to go through and factor out the top. And then factor out the denominator. And then this is already factored. And then this denominator, I can factor out an a. So once I have everything factored out, I put it underneath one big fraction bar because the order doesn't matter when you multiply. So I can cancel out the common factors. So these two cancel out, these two cancel out. So I'm left with a minus 2 over a times the quantity a minus 1. You cannot cancel out these two a's because they're stuck with the subtraction. So now if I look at my restrictions, I never want to divide by 0. So the situations for a that would make my denominator be 0 would be 1, -1, that comes from these two, 0, and -2. Those are my restrictions. So this is my solution, and then these are my restrictions. And then letter B is a division, so I'm going to just factor out this will be a plus 5, a minus 3 over, this will factor out to be a plus 4, a minus 4, and then a division symbol will, when you divide fractions, you flip and multiply, so this will be 3 times a minus 4 will go on the numerator, and then a plus 1 will go on the denominator. So I'm looking to cancel out any common factors. So it looks like the only common factors are those two right there. So my solution is going to be 3 times a plus 5, a minus 3 over a plus 4, a plus 1. So if I look at my restrictions, look at your denominators in the beginning, the middle, and the end. Technically, this was a denominator right here. So I need to make sure that I'm including this restriction. So this restriction will be 4, so a can't be 4, -4, 4, I already have that one taken care of, and -1. And again, I can't set 3 equal to 0, so that won't be a restriction. Okay, so when you're adding and subtracting fractions, remember you need to get a common denominator. And sometimes in order to get a common denominator, you need to factor. So I'm going to factor out this denominator. And then I'm going to factor out this denominator. And I'm noticing that they both have x plus 2 in common, but the left-hand side needs a 4, so I have to multiply it on the top and the bottom. And the right-hand side needs an x minus 6. So we have a common denominator. So I'm going to simplify the numerator is going to be 4 plus 3x squared minus 18x all over 4 times x minus 6, x plus 2. So I want to write this in standard form, the top. So it's going to be 3x squared minus 18x plus 4 over 4 times x minus 6, x minus 2. So before you think that you're done, what you really should do is see if the numerator can factor. Maybe this can factor out and cancel out one of these factors. So to check it, I do factors of a times c, so factors of 12 that add up to negative 18. Since there's no factors of 12 that add up to negative 18, this cannot factor any further, so this is my solution. Solve and check your solution. So in this case, I could cross multiply right here. I could do that, but I'm noticing that I already have a common factor, x plus 2, so that means I just need to multiply the top by 5. So then my denominators will be the same. So this is negative 4 over 5 times x plus 2 equals 15 over 5 times x plus 2. If you have denominators that are the same with an equal equation, that must assume that the numerators are equal. Well, the numerators are not equal because negative 4 does not equal negative 15. So this would be a case of no solution. You could also show it by checking this graph. You could put this in y1 and you could put this in y2 and you would see that they would not intersect. You can always check your answer that way too. And the last one is you have an equation. So what I'm going to do is and I have some fractions, so I'm going to get a common denominator. So it's going to be negative 2x minus 2 equals 2 over x minus 2, x plus 2, plus 5 times x plus 2. So looking at this with the common denominator, I'm going to have to put a x plus 2 on the left side right here, and the right-hand expression needs an x minus 2. So since my denominator is all the same, I really don't even need to pay attention to this anymore. So my expression's on the top, because remember when there's an equal sign and you have all the same denominators, you can assume that the numerators are equal as well. So it's negative 2x minus 4 equals 2 plus 5x minus 10. So negative 2x minus 4 equals 5x minus 8. So I'll add 8 would be 4 equals 7x. So x equals 4/7. So what you want to do is check, is 4/7 a restriction? Is 4/7 okay? Will that make my denominator 0? So it does. Then what you want to do is you want to plug in, because the direction's red to check your answer. So in that case, I mean, you need to show your check. You could also put this in your y1 and this in your y2 and see if those graphs intersect at 4/7. So fractions wise, negative 2x minus 2, what you want to do is, you want to plug in negative 2 over 4/7 minus 2. And you want to see if this is equal to, so you want to get I'm running out of time here, but you want to get a common denominator, or you want to subtract these two. So this would actually be 14/7. So this would be negative 2 over 4/7 minus 14/7 is going to be negative 10/7. So this turns into, multiplying by the reciprocal, would be negative 14 over negative 10, which would be 7/5. So you want to plug in 4/7 right here too, and make sure to both of these and see when you add these if you'll get 7/5.